Welcome to Mr. Chalk's Revision Tips. In this video, we will look at simple covalent molecules and giant covalent structures. So, a covalent bond is a shared pair of electrons. Covalent bonds result in the formation of molecules that can either be small or large. So, we'll have a look at how these covalent bonds form, how they go and the properties of simple molecules, and how they go and form giant molecules and the properties of these giant molecules. So, a covalent bond is a shared pair of electrons. Covalent bonding results in the formation of a molecule or a giant structure. Substances with small molecules have low melting and boiling points and do not conduct electricity. Giant covalent structures have very high melting points due to the number of bonds that will need to be broken. So a covalent bond is formed when two atoms share a pair of electrons. Covalent bonds occur in most non-metal elements and in compounds formed between non-metals. So these shared electrons are found in the outer shell of the atoms. So usually each atom contributes one electron to the shared pair of electrons. So we can see from the diagram on the left, we've got a hydrogen atom. The hydrogen atom wants to gain one more electron to get a full outer shell. The chlorine atom also wants to gain an electron to get a full outer shell. So therefore they share a pair of electrons, meaning that both will have a full outer shell. So if we have a look at a very quick question, so the hydrogen halides, so hydrogen fluorine, fluoride and hydrogen chloride are important chemicals. If we have a look at this, so what particles are represented by the X's, what type of chemical bond holds the molecule together, and what would you expect the hydrogen chloride to be, a gas, a liquid or a solid? Just have a quick think, then the answers would be the X represents an electron, the type of bond is a covalent bond, and we would expect it to be a gas because it is a small molecule, so therefore we'll have a low melting and boiling point because there are only weak forces in between the molecules. Hydrogen, ammonia, methane and water are also simple molecules with covalent bonds. All have strong bonds between the atoms, but weaker forces holding the molecules together. When one of these substances melts or boils, these weak intermolecular forces break because they're not strong and they are only forces, not physical bonds. So simple compounds are made up of only a small number of atoms. Covalent bonds form when the atoms share an electron or a pair of electrons to get a full outer shell. So you get strong covalent bonding between the atoms. However, only weak intermolecular forces between the molecules. So only a small amount of energy is required to break these intermolecular forces, which means that they have low melting and boiling points. So are usually gases at low temperatures, and especially room temperature. So we have a look at this question. So chlorine will combine with the non-metal element carbon to form this molecule. Explain how these bonds are formed. So if you just have a think about that, thinking back to the previous bit on the physical bonding. So your answer would have to make some reference to a shared pair of electrons, and our idea that a bond is a shared pair of electrons, and that's what's forming it. So another question might look something like this. So volcanic activity on the surface produced an atmosphere containing carbon dioxide, ammonia, methane and water vapour. Describe the bonding in one of these compounds. You must include the electronic structures in your explanation. So you could go and answer it, or your answer should include something about the outer electronic structure of an atom, the correct number of electrons are needed to complete that shell, the electrons complete the outer shell, one pair of electrons is in a covalent bond, and once an atom has a full outer shell, it can no longer bond with any more atoms because it doesn't need any more electrons. Giant covalent structures contain lots of non-metal atoms, so each are joined to an adjacent atom by covalent bonds. The atoms are usually arranged in a giant regular lattice, which is extremely strong because there are lots of bonds involved. So, if we look at this as an example, so silica is the main compound found in sand. It contains many silicon and oxygen atoms. So these are joined together by covalent bonds in a regular arrangement, forming a giant covalent network or lattice structure. So there is no set number of atoms joined together in this structure, so these covalent lattices are not classified as molecules. Giant covalent substances are solid at room temperature and have very high melting and boiling points. Covalent bonds are strong, so lots of energy is needed to break up these large structures during melting and boiling. Giant covalent substances have no overall charge and most do not conduct electricity. However, graphite, which is a form of carbon, does. A substance can dissolve in water if it forms a strong enough attraction with water molecules. However, giant covalent substances cannot form these attractions in water, so they are insoluble. So if we just have a quick review about the states of matter, because this is often linked to parts of questions when it comes to bonding. So remember solids. So solids is where all of the particles are held together in a fixed position and only vibrate around a fixed point. Liquids can flow over each other, so they move. The particles can move about, however they are all next to each other, so cannot be compressed. And gases, the molecules, have a lot of energy and can move in all directions. So if we have a look at this diagram, so 4 questions that you could be asked: which substance is a gas, which substance is a liquid, which substance is an element, and which substance is made from ions. If we have a quick think about this, then so the substance that is a gas is C, the substance that is a liquid is B, the substance which is an element is A, because A shows the structure of a giant covalent molecule, and a substance that is made out of ions is D, because the ions are charged. Thanks for watching.